Hiya everyone, and welcome to Debugging and Object Sorting. Let's just dive straight into it. As we acknowledge, as we acknowledge the Whadjuk Noongar people as the traditional custodians of the land of the Curtin University's Perth campus, and pay respects to elders past, present, and those who are emerging, also acknowledging the First Nations of all the countries in which we teach into. So, the unit learning outcomes, here they are. Again, these are the things that tie everything we do together. What's our outline for this session, for these sets of classes? Well, we're going to be looking at some software disasters, debugging, object sorting, and then what's called secondary sorting. Let's dive straight in now to software disasters, and there are countless software disasters. I want to ask you, what joins these projects together? The Mariner 1 space program, the Soviet gas pipeline, the Toyota Prius, the NHS, and of course, a lot more. Now, you're probably going, well, David, you gave us a really good hint. And that's right, I did. It is software disasters. Now these things tie all of those together. I think this may have been mentioned previously, but Lufthansa Flight 2904, a classic software disaster. All right. Now, I recommend you go out and have a read about this, particularly in the light of if statements, because this is a fantastic possible, I say case study, but it's just a great example when things go wrong. So, what are we looking at? Well, what we're looking at is when this plane was coming into land, we have some issues. The plane was flying from Germany into Warsaw. It lined up, it got all the information it needed. It was told there was a crosswind. Turned out to be incorrect. There was a tailwind, and that meant we had some problems. Okay, the problems being that when the plane lands, there's certain categories or certain things that need to occur. There needs to be, in this case, 12 tons of weight on each wheel. Okay. So, it's come into land, that's the first thing. Or, the wheels needed to be turning at more than 133 kilometers an hour. So we've got 12 tons on each wheel, on each of the wheels, and then we have wheels turning at 133 kilometers per hour. Okay? That's the speed. And when that occurs, we can engage reverse thrust. The challenge was, as this plane came into land, it came in faster because it turned out to be a tailwind. It landed slightly on an angle, which is quite normal for the plane, but it also aquaplaned. So none of those conditions were true. And because none of those conditions were true, it ran into a problem. It ran out of space to stop in the end. And that was all because of if statements, and if statements not really taking into account all possibilities. So what does your software do? Okay, are you sure your software does things right? Are you? Are you really sure your software does things correctly? Really? And are you really, and I go even further, really sure your software performs correctly? Things that you need to be thinking about. Does that happen? Does your software perform in the conditions that it's presented with as expected? Does it do what it's meant to do when it's meant to do it in the way it's meant to do it? If it doesn't, we've got a problem. Really? Absolutely. And this is where debugging becomes absolutely crucial. Now, debugging is a term that started literally because of a bug, okay? So we say in the beginning. So the first bug, the first problem, was actually a physical bug. And I say debugging began in 1945. There was an engineer, a female engineer, and they found a panel in moth F, a moth in panel F of the Relay 70 of the Harvard Mark II system. And what you see here, okay, all right, let me see. What you see here is actually the entry in their log, and this is the moth. Now that moth, you're going, how did a moth get in the way? How did the moth cause problems? Well, the moth got between two circuits and it prevented the electricity, and we had a problem. That's where the term debugging comes from, when it comes to software. So, what is it in our terms? In our terms, it's really that systematic process where we remove defects from our code. And the crucial thing that I'm talking about here is systematic removal. It's not ad hoc, it's systematic. There's a process that we go through. And as you go on further in your course, you will see this when you do things like software engineering testing. So we have two major defects, two major things that need to be debugged. The first one being what I will call compilation errors. Now for you in PDI, this is probably where you're at the moment. You go, oh, it won't compile, okay? And not syntax errors, syntax errors, okay? And you're going, oh, it won't compile, it won't compile. Let me assure you that as you go further into your software development career, you will end up longing for compilation errors. It's when your program runs, it executes, it functions absolutely superbly, except what you were expecting was something like that. And what did you end up with? We know something has gone wrong, okay? That here, these fall under this category where we've got logic errors. So our program may perform, it does things, but we get an answer we're not expecting. And when we debug, it's absolutely crucial we know what answer we're looking for, okay? When we run our code and we're testing it, we need to know, for instance, that. Because when our program does spit out something like that, were we expecting it? Because if we were expecting this, but we got that, and we knew that, then we know we've got a problem. It's when we don't know, or we don't know what to expect, we run into even bigger problems. So what are some of the debugging techniques? What are some ways? Well, we have coding techniques that allow us and assist. This is the most obvious one. From the very start, write perfect code. And then we're done. No need for anything else. We wrap this class up. That generally doesn't happen, okay? So some of these techniques, and you've been wondering, why do we only allow one return? Okay, so that last line of the function is where we allow the return statement. And the reason we do that is it's writing nice, clean code. There's one possible place where we exit from that function. And that means we don't need to go, oh, like that, because we can come down the code systematically. We know there's one place that we exit. That's it. Helpful. The break statement, only permitted in the switches, okay? Because otherwise, if we permit it everywhere else, it's like, well, did it break? Did it break? Did it break? So this is why break is permitted in our Java code in one single location. And we avoid continue statements. We haven't really touched on continue statements, but you will see them at some point in time. We avoid them so that we can trace the execution of the code much simpler. And we modularize our code. We build systematically functions that do one thing and one thing only, because then we know what the function is meant to do, and we can check it, we can test it and go, does that function perform the task it's meant to perform? If it performs 5 different things, then we've got at least 5 places of possible error. So some simple checklists that we can work with in PDI go something along these lines. Are you in the correct expected function? When the code is executing, is this where you expect it to be? Yes or no? Do the parameters contain the expected values? So you can test that within a function. Your first line inside the function, did the parameters come with the expected values? Yes or no? What about the calculation? Was the calculation that you performed correct? Because if it wasn't correct, we can fix it. Was it correct? Yes or no? Were the correct variables used in the calculations? We're meant to add 2 numbers together, x and y, or we're meant to find the distance perhaps between 2 points. Did we use the correct values in the calculation? And you're going, David, this sounds really obvious. Well, once you start writing code and your code has got 150,000 lines of code, things may not be as obvious. So were they the correct ones? Yes or no? Was the calculation's result assigned to the correct variable? Again, you're going, David, well, this one, if I come back up here, we assigned that. But what happens if somewhere in our code, we're checking multiple distances? Did we assign it to the correct one? That is really important. Did we? Yes or no? Was the correct value returned? You've performed the calculations. You've calculated in your function the distance between 2 points. Was that what was returned? Oops, no it wasn't. We actually returned the value of the latitude. Okay, we need to fix that. So was the correct value returned? Yes or no? And we can continue to build our checklists. And if you go online, you will find that there are 101 checklists that you can work with. And it's important, I would suggest, to develop your own checklists, things that help and support you as a software developer to write the best code and to find your own errors as soon as possible. So, answering the simple questions. I think I've pretty much gone through how we answer them, but one of the best techniques to do this when it comes to Java is that system.out.println. Okay, all the way back in that previous slide, do the parameters contain the correct values? System.out.println, the value of the parameter is, and we print it out. The value of the returned variable, or the variable we are about to return, is. The value of the calculation is. These are ways, this function here, that little line of code, that's it in Java. You'll see it, printf, print, all kinds of things in other languages. This becomes really important to debugging your code. What function you're in, the values of the parameters, the correct calculation, and the returned value. We can do those all with simple system.out.printlns. I recommend you leave that in your code and you simply comment it out, because if you need to change your code, you may want to retest it. Then you just uncomment and you're there. This system.out.println, I've said it already, but it's going to tell you absolutely amazing things.